Hello girls, today we're going to look at chapter 5.4, Dividing Polynomials, and this is considered part 1, long division. So we're going to look at dividing polynomials using long division today. You may remember long division from grade school math, where you learned to perform long division with numbers, and it looked something like this. We're going to use long division today to divide polynomials, so it looks very similar, but a little bit different because we've got equations instead of just numbers. So we found it helpful in the other classes to first go ahead and work through a long division problem just using numbers to kind of refresh your memory with the process. So for instance, let's just divide 525 divided by 3. Okay, and just to, again, refresh your memory, to perform this, you first think of how many times is 3 going to 5, and that would be once. And then you multiply. 1 times 3 is 3. And you subtract. 5 minus 3 is 2. Bring down your 2, the next digit. And how many times is 3 going to 22? Would be 7. So 7 times 3 is 21. Subtract. 22 minus 21 is 1. Bring down the next digit, which is 5. How many times does 3 go into 15? 5. 5 times 3 is 15. Subtract, and we get 0. So 525 divided by 3 equals 175. So again, since we have a remainder of 0, that tells us that 3 and 75 are both factors of 525. And we're going to use polynomial long division to try to find out the same information about equations. So just like we found out that these numbers are factors of 525 by dividing, we'll be able to find polynomial factors by division also. So let's get started. One thing to consider here that we'll talk about as it comes up in examples is when we start out, the equations must be in standard form, which again just means the highest power first and then decreasing exponents from there. And we may need to fill in some missing terms with using a 0 coefficient. And we'll talk about that as we see it in an example, but just something to keep in mind. Okay, so let's look at our first example. We set it up just like a long division problem with numbers. So we say 4x squared plus 23x minus 16 divided by x plus 5. Now, just like in numbers long division, we first want to see, actually, the question we're going to ask here is, what do we have to multiply this x by to equal 4x squared? And the answer would be 4x, right? Because 4x times x would give us 4x squared. So we're going to write that 4x above the x term in this equation. So here's the x term, so we're going to right above it write 4x. And then we're going to distribute this 4x to both of these terms. So 4x times x is 4x squared. 4x times 5 is positive 20x. Then we're going to subtract. So we want to draw parentheses and a minus sign because we want to subtract both terms. So 4x squared minus 4x squared is going to cancel out because that equals 0. 23x minus 20x equals 3x. Then we bring down our next term, just like in long division, a negative 16. And we again ask the question, what do we have to multiply this x by to equal 3x? And the answer would be a 3. So again, we write that 3 above the constant term in our polynomial, and we distribute that 3. So 3 times x is 3x. 3 times 5 is 15. And then we're going to subtract, again, both of those terms. So 3x minus 3x is 0, so those will cancel. negative 16 minus 15 gives us negative 31. Now at this point we really can't go any further because there's nothing that we could multiply this x by to get a negative 31. So we're finished now, and basically you're finished anytime your divisor over here is of a greater term than what you're trying to divide by. So in this case, like this is a constant, and x to the first is a higher power, so we're finished. So the answer to 4x squared plus 23x minus 16 divided by x plus 5, the answer is 4x plus 3 with a remainder of negative 31. Okay, so since this has a remainder, then we know that x plus 5 is not a factor of what we started with, just as we would in long division of numbers. Okay, so let's try another example. Okay, so in this example, we're dividing this polynomial by x squared plus 1. Now this is where I mentioned previously that first step you need to do is make sure you have all the terms necessary to perform that division. And what I mean by that is you want to look at your first term, your highest power, which in this case is an x to the fourth, and just to make the process go smoothly, we need to have a term for every degree from x to the fourth down to a constant. For instance, we have x to the fourth, x to the third, x to the second, but we don't have an x to the first. So we're going to have to add that in with the coefficient of 0. And then we have a constant. Same process over in our divisor. We have x to the second, but we don't have x to the first, so we're going to have to add that in, and then we have a constant. So let's set up the problem. So we have 3x to the fourth minus 4x to the third plus 12x to the second plus 0x plus 56 divided by x to the second plus 0x plus 1. Okay, now we're ready to divide. So our first question is, what do we multiply x squared by to get 3x to the fourth? The answer would be 3x squared. Now, since that's a squared term, we're going to write it above the squared term over here, just like that. Now we're going to distribute that 3x squared. So 3x squared times x squared gives us 3x to the fourth. 3x squared times 0x gives us 0x to the third. 3x squared times 1 gives us 3x squared. Now we're going to subtract. 3x to the fourth minus 3x to the fourth, that cancels. Negative 4x to the third minus 0x to the third gives us just another negative 4x to the third. 12x squared minus 3x squared gives us 9x squared. Next, we bring down our next term, which is 0x. And again, we ask the question, what do we multiply x squared by to get negative 4x to the third? And the answer would be negative 4x. So we write that above the x term here. And now we distribute. Negative 4x times x to the second gives us negative 4x to the third. Negative 4x times 0x gives us 0x to the second. And actually, if you wanted to, it doesn't make a bit of difference, but if you want to keep the rules of multiplication, we can make that minus 0x to the second. And negative 4x times 1 is negative 4x. Now we subtract. So negative 4x minus a negative makes it a positive, so those cancel. 9x minus a negative 0, again, it's just going to give us 9x squared. 0x minus a negative 4x really means 0x plus 4x, so we get positive 4x. And next we bring down our next term, 56. So now, again, we ask the question, what do we multiply x squared by to get 9x squared? And the answer would be just 9. So we're going to write that 9 above a constant term here. And now we distribute that 9. So 9 times x squared gives us, gives us 9x squared. 9 times 0x gives us 0x. 9 times 1 gives us 9. Now we subtract. 9x squared minus 9x squared cancels out. 4x minus 0x gives us 4x. 56 minus 9 gives us 47. Oops, sorry about that. Gives us 47. And again, now our divisor, this x squared, is higher power than that x. So we can't go any further. There's nothing we can multiply x squared by to get x. So we're finished. So our answer is 3x squared minus 4x plus 9 with a remainder of 4x plus 7. Okay, so again, that's our division problem. They are not factors of each other because, again, we have a remainder. So let's look at one last example. So we looked at 5x to the 5th minus 32, and hopefully in looking at this and minus 32 divided by x minus 2, and hopefully in looking at this you see that we're missing quite a few terms in this equation. Oops, sorry about that. Quite a few terms in this equation because we go from x to the 5th to a constant. So we're going to need to think about this equation really as x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 32. Again, we never know what kind of degrees our answer will be, so we have to take care of all the possibilities. So we need to fill in for any missing terms that we may not have written in the original problem. And we divide this by x minus 2. So we start the process by asking, what do we multiply x by to get x to the 5th? And the answer would be x to the 4th. So we put that above the x to the 4th term. X to the 4th times x gives us x to the 5th. X to the 4th times negative 2 gives us negative 2x to the 4th. And we're going to subtract. X to the 5th minus x to the 5th cancels out. 0 minus a negative 2x to the 4th gives us a positive 2x to the 4th. And we bring down our x to the 3rd. And we ask the question, what do we multiply x by to get 2x to the 4th? And the answer would be 2x to the 3rd. So we write that above our x third term. Distribute. 2x to the 3rd times x gives us 2x to the 4th. 2x to the 3rd times a negative 2 gives us negative 4x to the 3rd. We subtract. And we look at 2x to the 4th minus 2x to the 4th. Cancels. Oops. Sorry about that. Cancels out. 0x to the 3rd minus a negative 4x to the 3rd gives us a positive 4x to the 3rd. Bring down our next term, which is plus 0x to the 2nd. And again, ask the question, what do we multiply x by to get 4x to the 3rd? And that would be 4x to the 2nd. So we write that up here. Distribute. We get 4x to the 3rd minus 8x to the 2nd. Subtract. 4x to the 3rd minus 4x to the 3rd cancels out. 0 minus a negative 8x to the 2nd gives us a positive 8x to the 2nd. We bring down our next term, 0x. We think what we do, we multiply x by to get 8x. And that would be, to get 8x squared. And that would be 8x. Change colors here. And we distribute, so 8x times x gives us 8x to the second. 8x times negative 2 gives us negative 16x. We subtract. 8x squared minus 8x squared cancels. 0 minus a negative 16x gives us a positive 16x. Now we bring down our next term, which is negative 32. And we ask the question, what do we multiply x by to get 16x? And the answer would be 16. So we go up here and write 16. 16x, 16 times x is 16x. 16 times negative 2 is negative 32. We subtract, and now we actually have 16x minus 16x is 0. Negative 32 minus a negative 32 is plus 32, so it results in 0. So we have a division problem that ends in a remainder of 0. So now we know that x to the fifth minus 32 divided by x minus 2 equals x to the fourth plus 2x to the third plus 4x squared plus 18x plus 16. So now we do know from this answer with a remainder of 0, remainder of 0, that we know that x minus 2 is a factor of x to the fifth minus 32. Now, this is just one of the factors. Again, with it being an x to the fifth equation, we would expect 5 factors, but at this point, at this level, in Algebra 2, we won't go further in trying to find more factors. But we do know that this is one of them. X minus 2 is one factor. So, that concludes our lesson in long division. So again, what I encourage you to do is replay these notes if you need to, follow them as closely as you can, just to get the process down. Again, it's a little complicated, but this should give you the basis to be able to finish the homework assigned, which for this section was page 308, 10 through 16 evens. It is just 4 problems involving long division. So try the homework, do the best you can, and we can talk about it in class next time, or if you run into some problems that I could solve with email, just shoot me an email. And thanks, girls, and I will see you next class. Bye.